Greetings to all of you. In today's session, we are going to discuss about intermediate chemistry, which will be helpful if you are preparing for the entrance examination or competitive exams towards the international platform, or else in the India level JEE Advanced and JEE Mains for IIT and NIT entrance exams, NEET chemistry for medicinal entrance exam, Telangana and Andhra Pradesh exam for EAMCET, and that will be helpful for the BTech entrance examination. In addition to all these, if you are aspiring for any government exams, any government entrance examinations, competitive exams, for all these, the kind of session will be very much helpful. Let's enter into our today's session. Here, the question number 1 is given from IUPAC. Name the following compound as per the IUPAC protocol. IUPAC stands for International Union for Pure and Applied Chemistry. As per the IUPAC, we need to assign the name for these two organic compounds. One is said to be formyl chloride in general words, and second is called acetyl chloride. We need to give their IUPAC names. Let's see what will be the protocols provided by IUPAC in order to assign name for these two compounds. Here, HC double bond with Cl, if present, this carbon counts for its parent chain. Here we have one parent chain, one parent chain carbon, so that we can say meth. Here meth will be pronounced, and being it is the kind of acid derivatives called acid chloride, we can say. Acid chlorides always denoted with alkanoyl chloride. As per the IUPAC, alkanoyl chloride will be mentioned. That's the reason why, being one carbon organic compound, it will be methanoyl chloride will be taken. In the similar manner, second compound is of 2 carbon chain, and it is also acid chloride, we can say. Eth will be the root word, we can say, and the entire chain, parent chain, will be of ethanoyl, and the side chain, that means the functional group, will be chloride. Ethanoyl chloride will be the name. As per the IUPAC, here alkane is the root word, we can say. Oil is given for what? Oil chloride is given for the functional group which is provided in the given compound. COCl is the kind of oil chloride functional group. Okay, so when we combine all these, it will be pronounced as alkanoyl chloride. Alkanoyl chloride is the general pronunciation for what? Acid chlorides. Okay, these are derivatives of carboxylic acid, and alkanoyl chloride we have to pronounce. This is given by the IUPAC nomenclature. Fine. So according to that, in the starting compound we have 1 carbon, hence we can pronounce methanoyl chloride. And the second compound is having 2 carbon chain, hence we have to say ethanoyl chloride. This is the way you can give the name as per the IUPAC protocol. Question number 1, methanoyl chloride and ethanoyl chloride will be the correct answer. Move on to question number 2. This is collected from the Cambridge Assessment International Education. There is a table provided, and the table shows the masses of some of the ions in 1000 cubic centimeter of the fruit juice. One of the fruit juice is given to you, and its quantity is 1000 cubic centimeters provided. In that fruit juice, these many elements are noticed. These many ions are noticed. What ions? Calcium ion is there. First ammonium ion is there. Calcium ion is there. Chloride is there. Lithium is there. Magnesium, nitrate, phosphate, potassium, sodium, and sulfate. These many ions identified in the given fruit juice, and not only identification but also quantification, we can say. Their masses also got calculated, right? So measured masses in this 1000 cubic centimeter are provided. Ammonium ion is present in 43 milligrams. Calcium is in 79 milligrams. Chloride 135 milligrams. Lithium 1 milligram minute trace quantity, we can say. Magnesium 80 milligrams quantity. Nitrate 35 milligrams. Phosphate is in 120 milligrams quantity. Potassium 575 milligrams. Sodium 120 milligrams. And lastly, sulfate is 105 milligrams. So this is about called quantification of individual ions present in the given fruit juice. What questions are framed based on this data, we need to see. right? These many questions are there. Answer these questions using only information provided in the table. We are not supposed to use our own brain. Rather, we need to collect the information from this table only, right? Okay. So state which negative ion has the highest mass in the 1000 cubic centimeters of the fruit juice. Okay. Which negative ion is having largest mass, we need to assign. All these ions are provided in milligrams, no? So milligram values are provided. First of all, we have to sort out which are called negative ions. Any ion which is allocated with the negatively charged on its superscript, that is said to be a negatively charged one. Fine, anion we can say, right? Here you can find a chloride ion 135 milligrams, nitrate ion 35 milligrams will be there. Sulfate will be 105 milligrams. Only three anions you can notice, and the leftover will be all are cations only. Right, chloride is there, nitrate is there, phosphate is there, sulfate is there. 4 ions we can locate in this table. The question is, state which negative ion has the highest mass in 1000 cubic centimeters of the fruit juice. Okay, among these 4 ions, largest amount, chloride is of 135, nitrate is of 35, phosphate is of 120, sulfate is of 105. Obviously, chloride quantity is larger. Just we can sort out. That is only the thing required. Chloride is mononegative ion and it is of 135 milligrams of larger quantity among all the negatively charged ions. This is the way we can answer. First of all, we have to analyze what way question is asking. Right. Move on to question number 2. In the question number 2, give the formula of ion in the ammonium sulfate. Ammonium sulfate is the salt where cations are ammonium, anions are sulfate. This is found like this. So ammonium sulfate salt is provided here. They're asking for formulate the ions. What ions? Constituting ions they are asking for. Ammonium sulfate can be separately. That means ionic form it can be represented as ammonium ions are 2. So that let me put a 2 over ammonium ions and sulfate is represented like this. If you add this kind of salt to the water, so that ions will be separated. So ion separation can be freely mentioned over here. 2 ammonium ions followed by sulfate ion can be easily separated like this. This is the way we can answer. What are the formulating ions present in the ammonium sulfate? First of all, we have to balance their valencies. Why we are writing ammonium taken twice and sulfate only one? Because sulfate is of SO4 minus 2 and ammonium is of monopositive. Here you can see di-negative charge. Here you can see monopositive charge. In order to make the neutral salt, neutralization, that's the reason why. Let me put taken twice. Ammonium ions, constituting ammonium ions taken as a 2 times, because here positive charge can be repeated twice so that 2 negative charge will balanced. That's the reason why whenever ammonium sulfate added to water, ammonium ions 2 released, sulfate 1 ion will be released. This is the way we can answer this second question. Move on to question number 3. Calculate the mass of sodium ions in 200 centimeter cube of fruit juice. Within the data what they provided, entire data is provided for 1000 cubic centimeters, but within the third question they are asking for in 200 centimeter cube how much mass of sodium ions are present we need to assign. First of all, in the 1000 cubic centimeter we have sodium ions 120 milligrams. 1000 cubic centimeters contains 120 milligrams. Then 200 cubic centimeters, how much sodium ions will be there? So that we have to go for cross multiplication. 200 multiplied with 120 and upon 1000 will be taken, so that it will be 24 milligrams. So 24 milligrams of sodium ions will be resided in 200 cubic centimeters of fruit juice. This is the way we can answer the question number 2, right? So in question number 2, this is the data provided. As per this data, we need to solve the given problems, right? This is the one Cambridge Assessment International Education question. Move on to question number 3. Question number 3 is collected from JEE Advanced Question Paper 2021. Fine. For diatomic molecules, the correct statement about the molecular orbital formed by the overlap of two 2pz orbitals. Okay, so two 2pz orbitals when combined, what kind of statements provided are true for the given molecular orbitals? And this is regarding diatomic molecule only. So this is one collected from Vedantu answer. And let's see what will be the answer. Sigma orbital has the total of two nodal planes. If you see the sigma orbital, first of all we have to know how the sigma orbital formation is possible, how the pi molecular orbital will be formed. Sigma orbitals are formed by axial overlapping of atomic orbitals. Whenever atomic orbitals are combining on the same axis, that is said to be a sigma bonding. Whenever orbitals are binding laterally, top and bottom with respect to the axis, that is said to be a pi bond formation, right? Always sigma bond formation, sigma orbital total of two nodes can be located, because the two positive lobes when combined, what happens here, you can notice the nodes in between positive negative, nodes in between positive negative. So here two nodes you can clearly notice over here, right? So whenever sigma star orbital has one node, sigma star orbital, sigma bonding is called this one. Sigma anti-bonding is called this one, where you can't notice only one node, rather you can see two nodes. That's the reason why whatever assumption provided in the option number 2 may not be correct. XY plane, you can notice two nodes. No, here one node is there, here one node is there, and this is said to be anti-bonding. This is said to be bonding, this is said to be anti-bonding. Bonding orbitals, two positive lobes are combining. Positive, negative lobes are there, anti-bonding will be there. Where you can notice the two nodes as well. That's the reason why the assumption 2 may not be correct. Move on to third one. Pi orbital has one node in plane which is perpendicular to the molecular axis and goes through the center of the molecule. Pi orbital has one node, they are saying. If you see the pi orbital, so this is the one pi orbital will be there. So pi orbital, if you notice, you can locate one vertical and either horizontal plane. So that we can't say, that is also not the correct. Pi star orbital has one node in the XY plane containing the molecular axis. Okay, pi star means what? Anti-bonding molecular orbital will be there. Okay, so this is said to be bonding, sigma bonding it will be. This is said to be sigma anti-bonding. This is pi anti-bonding. This is pi anti-bonding, right? So what they are saying, pi star orbital has one node on XY plane, molecular axis. Okay, when you see this, this is said to be molecular axis. This is said to be what we can say perpendicular axis. Whatever the axis present with respect to the molecule is called molecular axis. If you are putting another plane, perpendicular means 90 degrees axis, right angle we can say. So if you are placing like that, that is said to be what? Perpendicular axis. Okay. On the molecular axis, how many nodes you can notice? Only one node will be there. That's the reason why option number 4 is correctly justifying. Okay, whatever molecular orbitals are present, so we are going to count the number of nodes located. In order to explain all these, first of all, we have to know what is meant by a node. Node is nothing but, here, if you see, this is the example picture I am providing for just understanding. So node is nothing but where we can't locate electron. Probability of finding the electron is 0. That is said to be node. Okay, if you see this double dumbbell is a d orbital, no? So these lobes are said to be orbital lobes. In between these lobes, you can notice some void, some gap will be there, where electron can't be located, electron can't be predicted. That particular region where orbital, where the place electron can't be found is said to be a node. Okay, in between the lobes, orbital node will be there. This is said to be vertical node, and if you notice this, this is called horizontal node. Where the electron probability of finding is 0 is called a node. Okay, as per that one, question number 3, option number A and option number D both are correct. Okay, So by this we completed question number 3. Move on to question number 4. In the question number 4, again it is collected from Vedantu. The correct options related to the adsorption process. This is the question given from colloids and adsorption physical chemistry, right? Regarding adsorption, what will be the correct answer? We have to predict. Okay, chemisorption results in a unimolecular layer. Always adsorption is categorized into two types. No, one is physical adsorption, second is chemical adsorption. So physical adsorption is nothing but whenever adsorption is the process by binding of two species. One is called adsorbate, second is called adsorbent. On whose surface adsorption is possible is called adsorbent, which is coming to participate or coming to occupy in the surface is called adsorbate. If both are bounded by chemical bonds, that is said to be a chemisorption. If adsorbent bounded with the van der Waals forces, then it is said to be a physical adsorption. Okay, they are saying about chemical adsorption results in the unimolecular layer. Let's see whether it is correct or not. And second is about enthalpy change during the phase adsorption is in the range of 100 to 140 kilojoules per mole. Okay, always remember adsorption is the process of exothermic. That might be phase adsorption or chemisorption. In both the cases, heat evolved during the adsorption process. Okay, but let's check whether it is correct or not. This whatever numerals provided, we will check whether it is correct or not. Move on to option number C. Chemisorption is an endothermic process. This is absolutely wrong. Just now we said that whatever the process, phase adsorption or chemisorption, both are the kind of exothermic only. Whenever adsorbate is coming and occupying the surface, then heat evolved during the process. So that endothermic may not be the correct option. Lowering the temperature favors phase adsorption process. Okay, so as we are lowering the temperature, phase adsorption will be carried. They are saying this. Here answer is provided. Among all four options, A and D are absolutely correct. Okay, let's see how can we explain A and D correct, B and C are wrong. Let's see about that. Okay, the first one is about chemisorption. Chemisorption results in a unimolecular layer. This is from Liber text chemistry. And here phase adsorption, you can see on phase adsorption process, this is said to be adsorbent. And whatever particles coming are called adsorbates. They are provided here. Adsorbent is there, adsorbate is there. Okay, these are tiny particles which are occupying on the surface, not a single layer. Rather, you can deposit so many. One after another, you can locate so many. That is said to be what? Phase adsorption. If you move on to chemisorption, there is certain site. There is a fixed position. The whatever atom is coming should fix upon that. Being it is a chemical process, adsorbent to react. They should interact. They should participate in the chemical reaction. That's why it is more specific, we can say. Whatever active sites are present, there only atoms coming should occupy, so that we can say it is a monolayered rather than multi-layered. Fine, chemisorption is a monolayered process. Fine. So what unilayer is nothing but monolayer only. This is exactly correct what they are saying. And enthalpy change during the phase adsorption is in the range of 100 to 140 kilojoules per mole. Phase adsorption is a kind of very weak. Forces are located. That's the reason why amount of heat evolved also very less. Let's see. In case of phase adsorption, around 20 to 40 kilojoules per mole of energy only released. Extremely less, because it is the kind of what somewhat weak forces are accompanied. That's why heat evolved is also very less, right? So here 20 to 40 kilojoules per mole, but the numerals whichever provided is somewhat high, so that we can cancel out this option number B. Move on to option number C. Chemisorption is an endothermic process. As of now, we said adsorption is the process of exothermic always. Okay, so that we can cancel out option C also. And D, lowering the temperature favors phase adsorption process. As already we are aware, Physisorption, where binding is somewhat weak in nature, so that whenever temperature, we are maintaining lower temperature, so that it is very convenient to occupy the particles and the surface of adsorbent. That's why low temperature, if we rise the temperature, whatever covered molecules are there, covered atoms are there, they easily expel. So that lower temperature more preferable for physisorption, right? So that this is also correct. D option is also correct regarding this adsorption. For question number 4, option number A and option number D are correct answers. Move on to question number 5. In case of chemisorption, let me extend one point over adsorption process. In case of chemisorption process, we have higher temperature, while adsorption process heat evolved will be extremely large, that is in the range of 82 to 40 kilojoules per mole, because of higher forces during the combination of adsorbate and adsorbent, so that high heat amount of heat evolved during, so that exothermic reaction only, but higher will be the force, being it is stable, right? So whenever molecule is becoming stable, then amount of heat evolved will be very high. Okay, so question number 5, this is collected from Gurukulam degree lecturer question paper. Okay, electrolytic reduction of alumina to aluminium by Hall-Héroult process is carried out. Okay, so reduction of alumina to aluminium. So here aluminium extraction is carried by electrolytic reduction process by applying the current. So alumina is the ore. Alumina is the oxide ore of aluminium. From this ore, aluminium metal, pure metal will be extracted. The method they are following is Hall-Héroult process. Okay, in this, what kind of assumption provided, statement provided will be correct? We have to check it out. Okay, in the presence of cryolite, which forms a melt with lower melting temperature. Okay, in the presence of cryolite, which forms a melt which lowers the melting temperature, melting point will be lowered. Let's see whether it is correct or not. Okay, so this is said to be what they are saying, Hall-Héroult process. In the Hall-Héroult process, what will be the starting material taken? Alumina will be taken. Alumina is called what? Alumina is Al2O3, aluminium oxide, right? So aluminium oxide, when inserted into this, you can notice the positive electrodes are there, negative electrodes are located. And in this, one of the arrow is provided that belongs to cryolite. The cryolite formula is provided as Na3AlF6. Sodium aluminium fluoride is called a cryolite. Okay, so what is the role of cryolite here? What cryolite will do? Let's see. Okay, these many applications we have for cryolite. Ne3AlF6 is the formula for cryolite. Except A, remaining all are the applications of cryolite only. What cryolite will do? Cryolite reduce the temperature with the where alumina melts. This is nothing but lowering the melting point value of alumina. This is only they are asking for. This is only required answer for us. In addition to this one, cryolite increase the conductivity. Being it is the ionic compound, electrical conductivity of electrolyte also rises. Cryolite provides the sodium ions that helps to carry the electric current. Sodium ions are higher tendency to pass the electricity, no? Being it is the metal, we can say higher conductivity, so that conduction property got raised. Cryolite reduces the working temperature. So for example, if the entire device is operating at 600 degrees centigrade, for example, when cryolite is added, we can operate conveniently at 400 also, because cryolite able to provide the environment where lower temperatures are preferable to carry the reaction, because that will reduce the melting temperature of alumina metal. So that's the reason why for question number 5, option number 3 will be the correct answer. Move on to question number 6. This will be the last question of the session, where it is given from coordination compounds of inorganic chemistry, crystal field stabilization energy. CFSE stands for what? Crystal field stabilization energy. A complex has the highest value of CFSE. What does it indicate? Okay, if the CFSE, crystal field stabilization energy value is higher, then what kind of consequences, what kind of impact it will possess? Let's see. Whenever CFSE values are larger, complex will be thermodynamically stable and kinetically inert in nature. So this is the right answer for question number 6. Let's see how can we justify this answer. First of all, we have to know what is meant by crystal field stabilization energy. Crystal field stabilization energy is nothing but whenever d orbitals are present, how many will be there? D orbitals are 5 in number. Whenever d orbitals are in interaction with the ligand, what happens? D orbitals will be splitted into lower energy level and higher. T to G, for example, lower energy, and EG is higher energy level. So in between these two kind of two set of orbitals, whatever distance we have, that distance is said to be crystal field stabilization energy. It can be calculated by, in order to calculate crystal field stabilization energy, delta T2G minus delta EG can be taken, and numerically T2G orbital energy is given by 0.4 and EG orbital energy is given by 0.6. Okay, so CFSE of T2G orbital, CFSE can be calculated by taking T2G orbital delta value minus EG orbital delta value, right? So then higher the CFSE, if its magnitude is larger, what will happen? Crystal field stabilization energy is important factor in the stabilization of transition metal complexes. Okay, so this is an indicator to measure its complex stability. Complexes with higher CFSE tends to be thermodynamically stable and kinetically inert in nature, right? So this is the way we can answer. Higher the crystal field stabilization energy, higher the thermodynamical stability is nothing but towards the heat it will be more stable, and moreover kinetically inert. So being it is stable, whatever reagents added, it won't be reacted, hence we can say kinetically inert in nature. Okay, so this is the way we can answer the question. For question number 6, option number 3 will be the correct answer. By this way entirely completed the session. Hope this explanation will be helpful for your preparation and everything will be very clear. I believe that, and I'm sincerely requesting that everybody like the channel, comment which part is really interesting for you, and share with the aspirants who are seriously preparing for any entrance or competitive examination. Subscribe the channel in order to get more such kind of updates in the near future. Thank you very much for your patient listening. Thank you one and all.